Hello guys, AS and A-level students. This is Wael Bashuri, the physics teacher. In this video I'm gonna solve paper 1, version 11, 2023, October, November. So let's directly start to question number 1. In this question we're telling you what is a reasonable estimate of the cross-sectional area of wire in a paper clip. First step, you have to estimate the diameter of the wire. Diameter can be estimated as 1 millimeter, so 1 millimeter, and this means the radius will be 0.5 millimeter. Change it into meter and plug it in the formula. Area equal pi r squared, which means 3.14 times 0.5 times 10th power of negative 3 to convert it into meter squared. And then on the calculator you get the answer to that, which is 7.85 times 10th power of negative 7, and this is option C. So option C is the correct answer. Question number 2. Which quantity is not an SI base unit? First of all, you have to memorize the 7 SI units here. What are the 7 SI units? You can list them: second, ampere, mole, kilogram, CD, candela, and meter, Kelvin. These are the 7 SI base units you have to memorize. Now, which one is not an SI base unit? Clearly, this is kilogram, this is Kelvin, and this is second. Clearly, option A is the correct answer. Question number 3. A student determines the acceleration of free fall by using a small metal ball as shown. When switch S is opened, the ball is released from an electromagnet and an electronic timer is started. The ball then falls vertically downwards. The timer stops when the ball hits the trapper or the trap door. The student measures the distance PQ, which means this distance here. Focus on this distance PQ, it's very essential in the question, between the electromagnet and the trap door. This distance and the reading on the timer are then used to calculate the acceleration of free fall. Of course, to calculate acceleration of free fall, he needs the equation S equal half AT squared plus UT. Since this ball falls from rest, so you can ignore UT. Now, what is needed here to calculate the acceleration of free fall? You need the distance fallen by the ball, and you need the time. The time you can take it from the timer, and the distance fallen you can take it from measurement on the diagram. So let's see here what we have. Here you have the ball. It was initially like this, then at the end it was like this. Now focus on the diameter of the ball. That's the diameter of the ball here. Now, what is the distance fallen by the ball? If you focus on this distance, you will find it that it is this distance from here to here. That's the distance fallen by the ball. Let's label it S. Okay, this means in order to calculate S exactly, in order to measure it exactly, which option of these do you need? Let's check them one by one. Which statement about the errors in the experiment is correct? The random error can be reduced by adding the diameter of the ball to the distance PQ. Now, random error is not estimated, is not calculated by this way. Random error can be eliminated by averaging or taking the mean and many other methods. So clearly option A and B are incorrect. Now the systematic error, this is error due to the system itself. So here you have to focus on C and D. The systematic error can be reduced by adding the diameter of the ball to the distance PQ. Now clearly adding diameter to distance will not give you the distance S. The distance S is equal to PQ, distance PQ minus diameter, and this is from the diagram, which means option D is the correct answer. Systematic error can be reduced by subtracting the diameter of the ball from the distance PQ. Question number 4. The diagram shows two coplanar forces P and Q drawn to scale. Force R is given by R equal Q minus P, which diagram represent R. Okay, first of all, we put them head to tail. Let's put P and Q head to tail and then connect between the start of the first and the end of the second. So if you put them head to tail, this is P. Here we need minus P, so let's take Q first. So this is Q as the same direction as here, and P is drawn this way. This is P. I don't want P, I want minus P. So I'm going to draw it this way. This is minus P. Clearly here the resultant must be connect the first of the start of the first one to the end of the second one, which means you connect like this. So that is the resultant. R, in this case option C. You see option C is parallel. This is parallel to this and exactly equal to it. Question number 5. A parachutist falls from a stationary balloon at time t equals 0. The velocity time graph for the parachutist from time t equals 0 until the time when he's just above the ground is shown. Which graph best shows the variation with time of the acceleration of the parachutist? Initially, when the parachutist falls, this is the parachutist falling. The weight is downward force and air resistance is upward force. Now initially there is a resultant force acting downward. So resultant force F net is acting downward, and this resultant force F net is equal to W minus R. Clearly, since the resultant is downward, this means the acceleration is also downward. So the acceleration initially is positive, which means you can eliminate C and D because the acceleration is negative here. Acceleration here is negative and the acceleration here is negative. Now let's discuss whether we have to choose A or B. If you look at initial seconds here from 0 and P, it's the same for both. The acceleration was decreasing because air resistance is increasing here. The resultant force will decrease and F equal ma. This means if resultant force decrease, acceleration decrease. So here the acceleration is decreasing in both cases. And remember, this is velocity time graph. The gradient of the graph is the acceleration. So the gradient initially here, if you draw a tangent here, then a tangent here, you can notice that the gradient is decreasing. Okay, then the acceleration becomes 0 between P and Q, and this is correct for both here and here. acceleration is 0 between P and Q because acceleration is a gradient, and here you have constant velocity, so acceleration must be 0. Now we have to focus on this part, on last part, between Q and R. If you focus on the gradient here, the gradient between Q and R must be greater than the gradient between O and P. So I repeat, gradient between QR is greater than gradient between O and P. So here the gradient is almost the same. So here the gradient is almost the same. So here the gradient is greater. This amount is greater than this amount. So option B is the correct answer. Number 6, a projectile is fired from point P with velocity v at an angle theta to the horizontal. It lands at point Q. Horizontal distance r from P after time t. Okay, the best way to solve this question is to use equations of motion, because air resistance is negligible, so you have constant acceleration. So S equal half AT squared plus UT. Here we're talking about the distance r, which is a horizontal distance. So I can replace r here in S. Half times A times T squared. Horizontally, when the projectile is moving horizontally, only the weight is acting, but the weight is vertical force. Since there is no air resistance, so there is no horizontal force acting, which means acceleration must be 0. So half times 0 t squared plus ut. Now, what is the initial velocity? If you take components for velocity here, v cosine theta. That's the horizontal component. The vertical component is v sine theta. So here you have to replace v cosine theta times t. And clearly, this is option A. So option A is the correct answer. Question 7. A man stands in a lift that is accelerating vertically downward as shown. So the motion is downward. The forces acting on this person are two forces, W and normal force coming from the left. Since the acceleration is downward, this means W is greater than N. So you can say W minus N equal mass times acceleration, which means F net equal ma. F net is W minus N. Now, which statement describes the force exerted by the man on the floor? By the man on the floor, or by floor on the man, in both cases, to every action there's an equal but opposite reaction. We're talking about N. So try to focus on N. Now, if you rearrange this equation, you can get W is equal to ma plus N. Now, if you compare W to N, clearly N is less than W, because you need to add a quantity to N to get W. Clearly N is less than W, so option D is the correct answer. It is less than the weight of the man. Question 8. A ball of mass 200 is thrown horizontally with a speed of 20 meters per second against vertical wall. The ball is in contact with the wall for a time of 0.10 seconds before rebounding back along the original path with a speed of 10 meters per second. What's the average force exerted by the wall on the ball? This is a momentum question, so let's start this way. F equal ma. So F is equal to mass multiplied by V minus U over T. That's the definition of acceleration. Now, if you sketch a quick graph for a quick diagram for this, it hits the wall with a velocity of 20 meter per second, and it rebounds again with a velocity 10 meter per second. So what is the change in velocity? Delta V. So delta V will be 10 minus 20. Here you have to take one of them minus, one of them plus, because we have change in direction. So you can see 20 minus 10, and this is 30. Now you can plug 30 in change in velocity, you have time, then you can calculate the average force. F equal, the mass is 200 times 10 to the power of negative 3 times change in velocity, which is 30, divided by time, which is 0.10, and then get the answer 60. So option B is the correct answer. Question number 9. In an experiment, a metal ball is dropped into a viscous liquid. The terminal velocity of the ball in the liquid is measured. The experiment is repeated 4 times. For each repeat, a change is made to one of the following: the density of the ball, the density of the metal of the ball, the height from which the ball is dropped, the density of the liquid, the depth of the liquid. Initially, if you immerse a ball in a liquid and the ball is moving downward, so what are the forces acting on the ball? You have the weight, which is downward force, and you have the drag force, that's the friction with the liquid, and also of course you have the upthrust, which is U. Okay, now the terminal velocity is affected by these forces, because you know force equal mass times acceleration. Force equal mass times acceleration. Acceleration is affected by the force, it's proportional to the force, and velocity is affected by acceleration, which means these forces can affect the terminal velocity. So let's see which one can affect. So here, if you write the formula for upthrust, upthrust is equal to rho GV. So clearly the density of the liquid can affect the upthrust, and then it can affect velocity. So density of the liquid can affect the terminal velocity. Now also W is equal to mg. And W is affected by the mass. So if the mass increases or decreases, W is affected. And we know that density is equal to mass over volume. So if density changes, mass will change, and then W will change. So this means the density of the metal is also important here. So then you can choose option B, 1 and 3. The height from which the ball is dropped does not have anything to do with forces here. The depth of the liquid does not have anything to do with forces also here. Question 10. 2 objects move towards each other along the same straight line. After colliding, the 2 objects stick together and are stationary. Which statement must be correct? Here you have to know that momentum is conserved. Momentum P is conserved. So let's check. The total kinetic energy of the 2 objects does not change during the collision. Remember, if the objects stick together, kinetic energy is not conserved. because part of the kinetic energy will be converted into heat. The total momentum of the two objects before collision is 0. Because the momentum is conserved, so the total momentum of the two objects before collision is 0. So this is the correct answer. Here we're telling you two objects move towards each other along the same straight line. After colliding, the two objects stick together and are stationary. So which means momentum after collision must be 0. So total momentum of the two objects before collision also must be 0. The two objects have equal masses. This is not necessary, maybe because maybe they have different speeds. So in this case, they will not be stationary after collision. D is also incorrect because the two objects have the same speed. Maybe they have different masses, so they will not be stationary. So this is incorrect. Question 11. A minimum torque 20 meters must be applied to the lid of a jar for it to open. The radius of the lid is 4 centimeters. What's the minimum force must act on each side of the lid in order to open it? Now the force, we know the torque. The torque is equal to force times perpendicular distance from the pivot. So the torque is 20 Newton meter. The force here is, we don't know. The distance is 4. The distance is 4 times 10 to the power of negative 2 after conversion to meter. And then you do the math. So option C is the correct answer. Question number 12. Uniform bar length L and weight W rest horizontally on two supports X and Y. Support X exerts a vertical force Rx at a distance L over 6 from one end of the bar. Support Y exerts a vertical force Ry at the other end of the bar. The bar is in equilibrium. What's the ratio of Rx over Ry? Okay, let's find some important distances here before we solve it. This is a moment question. So since the bar is L, this distance is L over 2. From here to here, it's L over 2. And also this distance from here to here is L over 2. So we subtract half L minus L over 2. Half L minus, L over 6 after having same denominator times 3 here and here. 3 minus 1, you get 2 over 6 L, and that is 1 over 3 L. This means that this distance here is 1 over 3 L. Okay, now you can take moments about the midpoint. So let's do that. Let's take moment about midpoint. So here you can see support Rx. So Rx times distance. Moment is force times perpendicular distance, which is L over 3, is equal to Ry multiplied by L over 2. Now if you rearrange this equation and do the math correctly, you can get Rx over Ry is equal to L over 2 divided by L over 3, and if you simplify it, you get 3 over 2 Option A is the correct answer. Question 13. A type of firework is made by connecting two rockets facing in the opposite direction to a rod that, as shown, the rod is attached to a frictionless pivot so that the firework can rotate in a vertical plane. Focus on this word, can rotate, which means resultant moment is not zero. Since it can rotate, resultant moment is not zero. The firework has weight W. The pivot exerts a force R on the rod and equal and opposite to W. So here, each rocket exerts a force of magnitude F on the rod at a perpendicular distance D from the pivot. The forces exerted by the rockets are always in opposite direction. Air resistance is negligible. Which statement is correct? I can directly choose here option D. The firework is not in equilibrium because the resultant torque acting on it is not zero. Remember, here we said it's rotating. This means resultant moment is not zero. So option D is the correct answer directly. Question 14. An object of weight W is suspended from Newton meter. When the object is completely immersed in water, the Newton meter reads P. When the object is completely immersed in oil, the Newton meter reads Q. What's the ratio? Density of oil to density of water. Okay, here you have to know that upthrust is weight minus apparent weight. So upthrust equal W minus P. P is the apparent weight here. And here the upthrust will be the original weight, which is W, minus apparent weight, which is Q. Now let us write the formula for upthrust. Upthrust is equal to rho G V. Rho here is for water, and here upthrust is equal to rho of oil G V. V in both cases is the same because it's the volume of the object. Now here the upthrust is different in both of the diagrams. So let's write here W minus P equal rho of water GV. And let's write here the upthrust is W minus Q is equal to rho oil GV. Now in order to continue solving, let us divide both equations to get density of oil over density of water. So let me divide now the equations. So if you divide the equations, rho oil GV over rho water GV, because volume is the same in both cases, is equal to W minus Q over W minus P. Here you can cancel G and G, V and V, and then you get the final answer, which is D. Option D is the correct answer. Question 15 now. A crate of mass 50 is pushed a distance 6 meters along a horizontal surface against a constant resistive force of 70 Newton. The crate moves at constant speed and then it is then lifted at constant speed through a vertical distance 1.2 meters onto the back of a lorry. What is the total work done in this process? Now, work done is equal to energy transfer. So work done equal energy transferred. So initially we have work done against resistive forces. So we can say W is equal to force times distance the force is 70 times distance 6 meters plus another type of energy is transferred, which is the object can gain gravitational potential energy, which is mgh. So let's write it here. W equal force times distance plus mgh. Mass is given 50 times 9.8 times the height, which is 1.2. And then on the calculator you get option D is the correct answer. So option D is 1000. That's the correct answer. Now 16. The input power of television is Pin. Useful sound and light power emitted by the television is P out. Efficiency. What is efficiency? Now we know that efficiency is useful power output over power input. So useful power output is P out. So here P out over power input, which is Pn. So option A is the correct answer. 17. A builder holding a brick of mass 3000 grams drops the brick on his foot. What's a reasonable estimate of the change in gravitational potential energy? This is super easy. GPE is equal to mgh. The mass is given, which is 3000 times 10 to the power of negative 3 times 9.8 times drops the brick on his foot. Let's estimate the height of the builder as, let's say, as an average of 150 or 160 centimeter. Of course, times 10 to the power of negative 2 to convert it into meters. Now you can choose the closest answer, which is option A. Option A is the correct answer. Question 18. An elastic cord of unstretched total length 16 centimeters, cross-section area 2 times 10 to the power of minus 6 meters squared is held horizontally by two smooth pins a distance 8 centimeters apart. The cord obeys Hooke's law. A load of mass 0.40 kilogram is suspended centrally on the rod. The angle between the two sides of the cord supporting the load is 60. What's Young's modulus? Now Young's modulus, according to the syllabus you studied, is sigma stress over epsilon. Sigma over epsilon, which means force over area divided by extension over original length. And if you simplify this, force over area times, if you do skip multiply flip, length over extension. This will be FL over AX. So here the original length is given, which is 16. Area is also given in the question. We need extension and we need the tension, the force. To calculate extension now, you can see here original length was 16 and final length was 24. Clearly extension must be 24 minus 16, which is 8. Now let's calculate the force from the diagram. Now here, the tension requirement in the question is to find the force, and the force here means tension. Now the tension in the cord T can be calculated from the components. So here the tension can be split into two components. This is horizontal component and vertical component. So this is T, the tension, and here you have the angle here is 30. So this is T cosine 30. And here you have the weight. the weight is at downward force, W is downward force. But remember, we have tension also from the other side. So you can have another force like this, which means here you have 2t cosine 30. And the horizontal component is not important. Of course, the horizontal component will be, in this case, t cosine 60, because here you have 60. Alternate interior angle as 60 here. Okay, now in order to calculate t, you can equate W and 2t cosine 30. So W equal 2t cosine 30. This means t is equal to W over 2 cosine 30. Okay, next step, you have to plug the information in the formula. So Young modulus is equal to the force, and the force is here. Now we have it. W is mg. Mass is given to us as 0.40 times g, 9.81, that's W, divided by 2 cosine 30, 2 times radical 3 over 2, that's cosine 30, multiplied by L. L is 16. So now times 16 times 10 to the power of negative 2 to convert it into meters. And this is divided by cross-sectional area times the extension. So divided by cross-sectional area. So what is the cross-sectional area here? 2 times 10 to the power of negative 6 multiplied by the extension, which is 8 times 10 to the power of negative 2. And then the correct option is found from the calculator. Option C is the correct answer. Okay, let's now continue. Which force extension graph shows plastic deformation of a sample of material? Plastic information is when the wire or the spring does not return to its original shape after removing the load. While elastic deformation, when you remove the load, the wire returns to its original shape. Clearly here you will have, because of plastic deformation, you will have permanent extension. And option D, here you have permanent extension. So option D is the correct answer. Number 20, two waves pass through a point. A graph shows the variation with time t of the displacement s of the two waves at point P. What is the phase difference between the two waves at point P? Okay, to find the phase difference, you have to focus on the difference between the two waves. So if you move, for example, the upper wave 1 square to the right, like this, the two waves in this case will be exactly in phase. So if you move this from here, from this point to this point, 1 square to the right, the two waves will be exactly in phase, which means the phase difference is 1 square. The phase difference between the two waves is 1 square, and 1 square out of the total length. The total length of the waves is 8 squares. 1, 2, 3, 4, 5, 6, 7, 8. So that's the wavelength. 8 squares. 8 small squares. 1 square is different. So 1 over 8 times 360, that's the total degrees in one wave or one cycle. And this is 45. Option B is the correct answer. Next question. Which row is correct for both progressive transverse waves and progressive longitudinal waves? Okay. Transverse waves they oscillate at right angle to the direction of travel. Longitudinal waves oscillate parallel to the direction of travel. And transverse waves can be polarized. Longitudinal waves cannot be polarized. So here, option B is the correct answer. Can be polarized. This is transverse waves. Longitudinal waves contain compression and refractions, while transverse do not. A toy drone emits a sound at constant frequency, 800 Hz. The speed of the sound in the air is 330. The drone moves along a straight path directly towards the observer and then continues in a straight line directly away from the observer. The speed of the drone is constant. What is the velocity of the drone when the frequency of the sound heard by the observer is 850? So this is a Doppler effect question. So let's solve. The formula is F observed equal velocity of the sound multiplied by F frequency of the source divided by velocity of the sound plus minus velocity of the source. So here we are told in the question away and towards. We don't know whether to take plus or minus. So let's leave it till the end. Now the observed frequency in the question is 850. So let's replace 850. Velocity of the sound is 330 times 800 velocity frequency of the source divided by 330 velocity of sound plus minus velocity of the source, and that's the requirement. The requirement of the question is to know plus or minus, away or towards, and to know the velocity of the source. Now if you rearrange this equation, you get 330 is equal to 330 times 800 divided by 850 divided by 850 and here you have 330 plus minus velocity of the source. This is the math after rearranging the equation. Now here you can see 330 plus minus velocity of the source, and then on the calculator let's calculate these. 330 times 800 divided by 850. So here you get 310.58. Now we have to decide what to choose, plus or minus, and away or towards. So clearly 330 plus a number will not give you 310. That's why I'm gonna choose minus. So 330 minus velocity of the source is 310.58. If you do the math here, you can get the correct answer, which is option C. So option C, magnitude of the velocity is 19, and this is from the equation, and towards the observer, because we have chosen the minus sign. So minus sign means towards the observer, and the calculation gives you 19. 23. Which statement about electromagnetic waves in a vacuum is correct. Okay, and 23, infrared waves have shorter wavelength than visible light. Here you have to memorize the sentence of ordering the electromagnetic waves or putting them in order. Ruby's mother is visiting Uncle Xiaomi gladly. Radio waves, microwave, infrared, visible light, ultraviolet, X-ray, gamma ray. When you go from left to right, lambda decreases. So remember the sentence, Ruby's mother is visiting Uncle Xiaomi gladly. Remember, Xiaomi starts with X. Okay, and here you can decide which option is correct. Infrared waves have shorter wavelength than visible light. No, because infrared comes before visible light. Microwaves have longer wavelength than radio waves. This is clearly incorrect from the ordering. C is the correct option. Ultraviolet waves have higher frequency. When you go from left to right, frequency increases. So frequency increases. So ultraviolet have higher frequency than visible light, and this is the correct answer. 24. Vertically polarized microwaves are emitted from a source. The microwaves are detected by a receiver that is connected to a cathode ray oscilloscope CRO. The waveform displayed on the screen of the CRO has an amplitude of 2.6. A metal wire grid that acts as a polarizing filter is now placed between the source and the receiver. The filter is oriented so that the plane of polarization of the transmitted wave is at an angle 20 to the vertical. The distance between the source and the receiver is unchanged. The setting on the CRO are also unchanged. What is now the amplitude of the waveform displayed on the screen of the CRO? Now, the equation for this question is very easy. Amplitude is equal to initial amplitude A0 times cosine theta. Initial amplitude was 2.6 times cosine 20. And then you get option D. Number 25. In an experiment, a stationary wave is formed on a string stretched horizontally between two fixed points. So here you have two fixed points, and here you have the string. The string oscillates between these 2 points. Which statement about the experiment is correct? At certain times, the string between the two nodes is horizontal, with all points having zero displacement. Now, here it oscillates this way, up and down, but at certain time it will be horizontal. So option A is directly correct. 26 now. A musical organ produces notes by blowing air into a set of pipes that are open at one end and closed at the other. The speed of sound in air in the pipe is 320. What's the lowest frequency of sound produced by the pipe of length 10? Now, here we're saying to you, lowest frequency. At lowest frequency, this is the pipe, you have 1/4 lambda inside the tube, like this. So at lowest frequency you have 1/4 lambda, which means length of the tube will be 1/4 lambda, and this means lambda is 4L. Now what's the lowest frequency? V equal F lambda 320 frequency times wavelength. So now you can replace lambda. So it's lambda here, 4L, and the length is given 10 meters. So 4 times 10. After doing the math, you get option B. 27. In an experiment, water waves in a ripple tank are incident on a gap as shown. Some diffraction of the water waves is observed. Which change to the experiment would provide better demonstration of diffraction? Now, for better demonstration of diffraction, the gap size must be equal to the wavelength. So this is the wavelength from here to here. The gap size is too much. So how can you make the gap distance, or the gap is equal to the wavelength almost? Which option do you choose? Clearly, here you have to increase the wavelength. So if you increase the wavelength, the wavelength will be similar to the gap. So option C is the correct answer. Light of wavelength lambda is emitted from 2 point sources R and S and falls onto a distant screen. At point P on the screen, the light intensity is 0. What could explain the 0 intensity at P? 0 intensity at P means here at P they have to meet out of phase. So at P here they must meet out of phase. Out of phase. So when they meet out of phase here, they will cancel each other. So let's see the options. Light from the two sources is emitted 180 out of phase, and the path difference to P is half lambda. Since they are emitted initially out of phase here, and the path difference is half lambda here, this means they will meet in phase at P, so this option is incorrect. Light from the two sources is emitted in phase, and the path difference is lambda. This will give maxima, which means this is incorrect. Light from the two sources is emitted 90 out of phase, and then path difference is lambda. 90 out of phase cannot cancel at P. Option D, light from the two sources is emitted in phase, and path difference to P is half lambda. So here option D is the correct answer. Okay, now question number 29. A beam of red light, wavelength 720 nanometers, is incident normally on a diffraction grating and produces diffraction pattern on screen placed parallel to the grating. The beam of red light is replaced with a beam of electromagnetic radiation of wavelength X, which is incident normally on the same diffraction grating. The third order maximum for the electromagnetic radiation of wavelength X is the same. So here the same means angle theta is the same. So sine theta will be the same position on the screen as second order maximum for red light. So the formula for this question, N lambda, so N lambda equal D sine theta. Initially we have red light, and which order is it? The third order maxima for electromagnetic radiation wavelength X is the same position on the screen as the second order maximum for light. So this is second order here. 2 times lambda for light, 720 for red, equal D, we don't know it, and sine theta we don't know it, so let's leave it like this. Now this is the first equation. The second equation is order 3, third order maximum for the electromagnetic radiation wavelength x. So here you have to write 3 times lambda, we don't know, this is what we're looking for. D sine theta is the same. Now if you divide both equations by each other, you get 2 times 720 divided by 3 times lambda is equal to d sine theta divided by d sine theta, and these are cancelled together. You get 1 here on the right, so if you cross multiply and rearrange, you get 2 times 720 equal 3 times lambda, and this means lambda will be 2 times 720 divided by 3. 2 over 3 times 720, and this is option A. Option A is the correct answer. The current I in a conductor is given by the equation. What does this letter N represent in this equation? Okay, letter N is very clear. It is the number of charge carriers per unit volume. So option C is the correct answer. In a circuit shown, the battery has an electromotive force EMF of 6 volts and negligible internal resistance. The 3 resistors each have resistance R. Total power dissipated in the resistor R in the resistor network is 24 watts. What's the value of R? Now we know that power, the formula for power is equal to V squared over R. The voltage we have it, which is 6. Power we have it, which is 24. So 24 is equal to 6 squared over R. If you rearrange it, you get R is equal to 36 over 24. Now that's the total resistance. Now we put the formula for these resistance network. Here you have R and here you have 2R. The combined resistance in this case will be 1 over R total is equal to 1 over R1 plus 1 over R2. Now 1 over R total, which is 36 over 24, is equal to 1 over R1, which is R, plus 1 over R2, which is 2R. Now here you get 24 over 36 is equal to, if you do same denominator here, multiply by 2 up and down, so you get 2 plus 1, 3 over 2R. If you do now the math, 24 times 2R equal 3 times 36, then R will be 3 times 36 divided by 2 times 24. And here you get option D. So option D is the correct answer. Which graph could show how the resistance R of a filament lamp varies with the applied potential difference PD as V increases to the normal operating PD? First of all, we know that resistance increases with temperature. So that's the main graph for filament, voltage and current here. You see here, the gradient is the resistance equal gradient. And the gradient here is very clear, it's increasing. So resistance increases with temperature. Option A, we have resistance is increasing. So option A is correct. Option B, resistance is increasing to become constant at the end here. the line is almost becoming horizontal. This is incorrect. Option C, resistance is constant, and this is incorrect. Option D, resistance is decreasing, and this is incorrect. 33, a piece of conducting putty is in the shape of a cylinder, length 60 millimeters, diameter 20 millimeters. The resistance between the ends of the cylinder is 20 ohm. What is the resistivity of the putty? Now, the formula here is R is equal to rho resistivity times L over area. Now we plug the information in the given information on the equation. Resistance is 20, so 20 is equal to resistivity we don't know. The length 60 millimeter, 60 times 10 to the power of negative 3 divided by diameter. We can calculate the area, pi r squared. R is 10, convert to meter, times 10 to the power of negative 3, and this must be squared. If you rearrange it, you get option B. So option B is the correct answer. Next question. Which statement about electromotive force EMF of a cell is always correct? First option, the EMF is the energy converted from electrical to other forms. No, this is incorrect. It's converted from chemical to electrical. Option B, the EMF is the energy provided by the cell per unit charge passing through it. Option B is correct answer. The EMF, option C, the EMF is the potential difference across the internal resistance. This is incorrect because this is the terminal voltage. Terminal voltage. The EMF is the potential difference across the terminals of the cell. This is also incorrect because when the cell is supplying a current, the EMF, the voltage or the terminal voltage also can be measured from the terminals of the cell. So this is also the terminal voltage. Question 35. Kirchhoff's first and second laws are consequences of conservation of which quantities? Charge and energy. Kirchhoff's first law is charge and second law is energy. Clearly option A is correct. Question 36. Circuit contains a cell electromotive force E. Internal resistance R connected to a resistor of resistance R. The current in the circuit is I. Which equation is correct? We know that the equation of the EMF is equal to lost voltage plus terminal voltage. Which means EMF is equal to RI plus RI. Lost voltage, which is voltage because of the internal resistance. Now here, if you rearrange, you can get E is equal, or E minus RI is equal to IR, and this is option A. Option A is the correct answer. Question 37. A potential divider consists of two resistors of resistance R1 and R2 connected in series across a source of potential difference PD Vn. The PD across R1 is Vout. So which changes to R1, R2 will increase the value of Vout. Now the formula for potential divider here is V out is equal to R1 over R1 plus R2 times Vn. In order to increase V out, clearly we have to increase R1. So if we increase the numerator, V out will increase. Also, we have to decrease R2. If you decrease the denominator, V out will increase. So question 37, option B is correct. 38. Two alpha particles with the same kinetic energy are moving towards and then deflected by a gold nucleus. Which diagram could show the path of the two alpha particles? Okay, let's see them one by one. Option A, we see attraction between alpha and the nucleus, and this is incorrect. Option B, this deflect in a small amount and this deflect in a large amount. This is incorrect. The closer to the nucleus must deflect more. Here again in option C we have attraction. This is incorrect. Option D is the correct answer. The closest to the nucleus will deflect at a large angle, and away, and the alpha, which is away from the nucleus, will deflect at small angle. So option D is the correct answer. 39. Which nuclide is formed when C10-6 undergoes beta decay? So let's write the equation of beta decay. C10-6 will give beta plus. Here you have 0 and here you have plus 1. This is beta plus. Plus, we don't know here, we don't know the new nucleus, but the numbers must be balanced on the top and on the bottom. So here you have 10 plus 0, you get 10. So here you have 10, and here you have beta plus must be 5. Let's repeat again the equation. 1 second. So here you have carbon 10-6 will give beta 0 So here you have C10-6, 0 plus 1, plus we don't know the nuclei, the new nucleus, but here the numbers must be balanced. So here you have 10, because 10 plus 0 will give you 10, and here you have 5, because 5 plus 1 will give you 6. So option C is the correct answer. Last question. A particular hadron is composed of 3 quarks and has 0 charge. What is a possible quark composition of the hadron? Now here you have to know the 6 types of quarks. You have up, you have top, and you have charm. And all these are 2 over 3 plus 2 over 3. The charge is 2 over 3 of the electric charge. So all of these are 2 over 3. Then up you have down, and top you have bottom, charm you have strange, and these are minus 1/3 all of them. So memorize these charges. Now to get 0 as required here, which option will give us 0? If you look at option B, up, down, strange, let's calculate. 2 over 3 Down is negative 1 over 3, and strange is negative 1 over 3. All of them will add up to 0. Option B is the correct answer. And like this, we have solved this paper. Hopefully, you understand every single question, and thank you very much indeed.